Welcome to this video on resistance and Ohm's law. This session is designed to help you master key concepts in electricity for your GCSE Physics exam. In this video, we will explore what resistance is, define Ohm's law, discuss ohmic and non-ohmic components, and cover the required practical for your exams. Let's begin with Chapter 1. What is resistance? At its core, resistance is a fundamental property of electrical components that opposes the flow of current. Think of resistance like friction. Just as friction slows down moving objects, resistance slows down the movement of charge in a circuit. Higher resistance means less current flows. Resistance is measured in ohms, symbolized by the Greek letter omega. You will also see kiloohms and megaohms used when describing very high resistance values. There is an inverse relationship between current and resistance. If the voltage stays constant, increasing the resistance will cause the current to decrease. Moving on to Chapter 2, Ohm's law. This is the mathematical relationship that links voltage, current, and resistance in a circuit. Before calculating, remember the three units: voltage in volts, current in amperes, and resistance in ohms. These are essential for accurate circuit analysis. Ohm's law is represented by the formula V equals I times R. This states that current through a conductor is directly proportional to the voltage applied. You can rearrange this formula using the triangle method. Cover the variable you need to find to reveal whether to multiply or divide. Let's practice. If a resistor has 12 volts and 0.5 amperes, you find resistance by dividing 12 by 0.5, giving us 24 ohms. In this example, we calculate current. Dividing 3 volts by 6 ohms gives us a current of 0.5 amperes. A critical detail for your exams: Ohm's law only holds true if the temperature remains constant. If a component heats up, the law no longer applies. Chapter 3 focuses on ohmic versus non-ohmic components. It is important to understand how they differ in their behavior within a circuit. An ohmic conductor maintains constant resistance. Their current voltage graph will always show a straight line passing through the origin. For an ohmic conductor, the IV graph is a straight line through the origin, which shows that resistance remains constant. The gradient of this line, isone over the resistance. Some components are non-ohmic, meaning their resistance changes with voltage or current. Key examples include filament lamps and diodes. In a filament lamp, as current flows, the wire heats up. This increased temperature makes metal ions vibrate more, which leads to increased resistance. Because the resistance of a filament lamp increases with temperature, its IV graph is a curve rather than a straight line. It is symmetrical, as the lamp functions both ways. Diodes only allow current to flow in one direction, known as the forward direction. In reverse bias, their resistance is so high that virtually no current flows. The IV graph for a diode shows a threshold voltage, around 0.7 volts for silicon, before current rises steeply. In reverse, the line stays near zero. Learning to distinguish these IV graph shapes is a vital exam skill. Each curve or line shape tells you specifically how that component's resistance behaves. Now let's move to Chapter 4, the required practical. This investigation is a staple of GCSE Physics exams. The goal is to measure current and voltage for different components like resistors, lamps, and diodes to determine their electrical characteristics. To set this up, you'll need a power supply, a variable resistor to control current, an ammeter in series, and a voltmeter in parallel. The variable resistor is key. By adjusting its resistance, you can precisely control the current flowing through your test component to collect data points. The procedure involves setting up the circuit, adjusting the resistor in steps, recording readings, and repeating them to ensure reliability. Taking repeat readings helps reduce the impact of random errors. Calculating a mean value gives you much more reliable results for your analysis. Always remember to keep temperatures constant by switching off between readings. Unintended heating will ruin your results and make the test unfair. Finally, when plotting your graph, label your axes with units, choose a sensible scale, plot each point accurately, and draw the correct line of best fit. Once your graph is plotted, you can calculate the resistance. For an ohmic conductor, the resistance is constant, so you can pick any point to calculate it using R equals V over I. For non-ohmic components, the resistance changes. You must specify the voltage for your calculation. Simply read the corresponding V and I values from your curve at a specific point. Anomalous results don't fit the pattern of your data. When plotting, you will see them sit well away from your line or curve of best fit. If you spot an anomalous result, circle it and do not include it in your line of best fit. If possible, repeat that measurement to check for errors. Anomalies are often caused by misreading meters, loose circuit connections, or unintended temperature changes during a specific measurement. Moving to Chapter 5, Key Exam Tips. These are the crucial points that help you secure full marks and avoid common pitfalls in your GCSE Physics exam. Remember, Ohm's law requires the temperature to stay constant. Examiners specifically look for this condition. Without mentioning constant temperature, your answer is incomplete. Be ready to sketch and label all 3 IV graph shapes: the ohmic resistor's straight line, the filament lamp's curve, and the diode's unique asymmetrical shape. Don't lose marks on units. Current is in amperes, voltage in volts, and resistance in ohms. Always include these clearly in your final exam answers. To wrap up, remember to control temperature by switching off between readings, always repeat and average your data, and use your best fit line to analyze your results.